The last example that we did with the cylinder with the two spheres stuck on the end is something called a composite object. And you did this a little bit already in grade 9 math, and so this is a bit of a review. But sometimes we have composite objects. When we ask to find the volume of composite objects, it's pretty straightforward. When we ask to do the surface area, it gets a little bit more complicated. But for volume, if I want to find the volume of this, I can start by not highlighting, but taking out a pen and writing down what are the two shapes. I would have to add the volume of the hemisphere plus the volume of the cylinder. So I can write it out in words first. Lots of people don't write it out in words. They just visualize it and say, that's the two shapes that I have, so I need to add those together. Then, once they have the ideas there, some people calculate them separately. Say, okay, I'll calculate the volume of the hemisphere, and then I'll calculate the volume of the cylinder, and then I'll add them together. Perfectly fine. Some people take and just plug in the formulas all into one. So you can choose what you like better. Either A, you write next, you make a little note, I'm going to find the volume of the hemisphere, put the formula, figure it out. Then I'm going to find the volume of the cylinder, use the formula, figure it out. If you like to do it all together, your volume of your hemisphere is half your volume of your sphere. Your volume of your cylinder is the circle at the bottom times the height. And now you have to look through your formulas and say, do I know all the information for these formulas, or do I need to do some extra work first? Do you know the radius? Yes. Do you know pi? Yes. Do you know the height of the cylinder? Yes. So we're actually good. We can do this one. We have 1/2, 4/3 pi. The radius is 18 cubed plus pi. The radius is 18 squared, and the height is 32. And you can plug all of those things all at once into your calculator. Practice. It's just so if you're doing it all at once, I would say practice. Can you get this into your calculator and get the same answer that I get? Now, that's not to say that there's going to be times where I type it into my calculator and I make a mistake. But it looks like I've got everything typed into my calculator correctly. How do you write a half? You have, probably you would do 1 divided by 2. That would be the same thing as a half. Or you could change it to a decimal and write 0.5. Yes. You can put it in brackets, or you can go times pi if you like. Some calculators you can just write pi. You know what's really nice about your calculator? Just check this button out, this green one with SI. Oops. Alpha, this one. Yeah. I'm just going to clear everything out. Alpha, this one, you can do 1/2. Bracket. Alpha, this one, 4/3. Pi, bracket, 18, bracket, cubed. So you can really make it look like that, which is super nice, hey? The little hat button. 3. And then close that bracket there. Yes, so please type this into your calculator to see if you got the same answer. Yeah, we're going to be there in a second. I'll come in around checking calculators. I think on this one, good, 1/2 bracket. And then I think on this one, you might have to go times pi. Okay. Times. Oh, it's 18 cubed. Okay. Yeah, this little 3 here. Okay. So check it again, see if you get the right answer this time. Can I borrow your calculator for a second, Blue? Now, you've got.
I got it right this time.
I know this is the first edition. This is second edition. What's
That's the newer
interesting?
version, yeah.
Yeah, I know, but what's
They're the exact
interesting?
same.
I know, but look. So, you had the fraction. He doesn't. So I'm gonna see if I can get his.
Mine, yeah, like comes up as an actual fraction.
Yeah.
Just a bunch of numbers.
Set up.
Costco calculator, that's why.
Well, these are Costco as well.
Yeah, I had one of those and it ended up with my brother instead of me.
Okay. All right. I'm sorry. I was playing around with your calculator. It's all back to normal. Okay, next question. Maybe, there we are. Determine the surface area. Now, for surface area questions, it is not as simple as just adding the two surface areas together. So normally with volume, the total surface area would be the surface area of the, I should write it like this. What are the two shapes that we have? We have a prism plus the surface area of the pyramid. But it's not as simple as just adding the surface area of the one plus the surface area of the other one. And the way that I like to describe this is if I put two composite objects together, ooh, I might even have a little pyramid. Let's see if I have one. Ah, no, oh, wait. Come on, maybe. Close enough. Yes, I got it. You may. Look at that. All right, again, sharp pointy object. Just checking, just double checking. Everybody's still good. So now, if this was my composite object, okay, and I dipped it in paint, it would come out completely painted. What color did I pick? Red? Completely painted in red. Okay? Right? The red is the entire surface area. Just let me explain this first and then I'll get your question. Now, if I took the two parts apart, something's not painted red. The bottom, and then there'll also be a square, wherever this was, I pop it off, there'd also be a square on this that's not painted red. So when we do composite objects and we just add them together, we're going to be adding too much. Because if this whole thing was painted in red, I pop them apart, I need to subtract two squares. Does that make sense? Okay? And now when we look at this, this might be one that I do separately because we don't really have a good surface area formula on our formula sheet for prisms, right? And I just sort of mentioned that how do we figure out prisms? We just have to do all 6 sides. So this might be one that I do things separately. I'm going to figure out the surface area of my entire prism first. And do you see that there would be 6 sides, and each side is 5 times 5? Because it's a perfectly square prism. All the sides are the same. So the surface area of my prism is going to be 150. Yes, Brielle, you had a question. You can. I thought that might be. So this will be 150 meters squared is the surface area of my prism. The surface area of my pyramid. Again, that's not on our formula sheet. So we're going to have to do, how do we figure out the surface area of our prism? We have a base plus 4 triangles. The base is 5 times 5 because it's a square. Plus the 4 triangles are base times height, and they did give us the slant height, which is the height of the triangle, divided by 2. Okay? And I would get 25 plus 10, 35 meters squared. So then my total surface area is going to be the 150 plus the 35, and I still need to subtract the 2 squares. So that will be 2 times 25, or 50. And my final answer is 135 meters squared. Now, I wrote it out as surface area plus surface area minus 2 squares. It is not wrong if your brain says, oh, I'm just going to subtract the squares right away. So when I do the prism, I'm not doing all 6 sides. I'm only doing 5 sides. Would some of you think that way? Like this, it's the bottom, and then 1, 2, 3, 4. There's only 5 sides that are showing, so I'm only going to do 5 sides. And when I go to my pyramid, why am I doing the base? I don't need to. I'm just going to do the 4 triangles. So there are, if that is how you envisioned it, perfect. Okay? Sometimes that works better. Maybe it's a little bit less work for you. Great. Sometimes it might be better just to do the whole thing, like in the example, oh, and I put it away. This one, where the square that's on the top, when I pull it off, there would be like a weird square shape here. It makes way more sense to subtract it rather than to have it calculated separately. Okay? So depending on the situation, there may or may not be better ways to go about it. Yeah, 1 square is 5 times 5, but I have to take off 2 of them because there's a square missing at the top and the square missing on the bottom of the pyramid. Yes! Oh, good. I missed that, right? The answer makes no sense. There was 4 triangles, and I forgot to multiply this by 4. Okay, I'm sorry. So what will that become? Okay, 1 triangle is 10 times 4 is 40 plus 25 makes this 65 instead, which makes this part 65. and makes our total adding. Does that look better? Well, if we look at how many triangles there are on that pyramid, there's 4 of them. I even wrote 4 triangles, and then I forgot to times it by 4. Okay? What probably, or if I look back in my brain's history of what I was doing, and this happens often when you're doing math, I started to think about the next step too early. And then I forgot something simple in a step before. Question? What's that? What do we got? 2 more questions? Is this the last one? Last one. So it's emotional back end of the unit. So sad. But we get to pointy objects next. So that'll be a lot of fun. Okay? So surface area. Okay? Maybe I think I want to do the surface area of my prism plus the surface area of, this is another prism, triangular prism. And then what would I have to subtract? 2 rectangles. Yeah, basically like 2 squares. We have 2 different prisms here. Do you see that you have a rectangular prism? Maybe I'll write it like this. What's the surface area of the rectangular prism? You have 6 sides. You have 2 of them. You have ones like this, 2 times this one, and 2 times this one. You have the 4 and the 5. You have the 4 and the 6. And you have a 5 and 6. Length times width for area. Does it make sense? This one is 20, this one is 24, and this one is 30. So if I have 2 times 20 plus 2 times 24 plus 2 times 30, I add those up, 148. And this is why I like writing something out at the beginning, because you can get bogged down in calculations that you forget, what was I doing? Where was I? But now that I've written things down, I was like, well, oh, I just found out the surface area of the rectangular prism. As far as what I wanted to do, I can review this in my notes. I'm like, oh, I've just done this one little part. I still need to do the surface area of my triangular prism. So by keeping things nice and organized this way, let's do our triangular prism next. Can you see that your triangular prism would have 2 triangles and then 3 rectangles? Are the rectangles different? Yes. 2 of them are the same and 1 of them is different. Can you see that the one rectangle on the bottom is a 6 by 5, and then this rectangle is a 6 by, something, and we have 2 of those. And what can I label on my triangle? I know my triangle has a base of 4 and a height of 3. Do you see a problem that we have? We are good for our triangle formulas. We can do base times height divided by 2, and then we have 2 of them, so times it by 2. We have 6 by 5. This one is easy to figure out. Its surface area is 30, but we have a problem here because the rectangles that make the roof, we don't know how long this orange side is. So then we have to take a step back. Is there something that we could do to figure out that orange side? Oh, but where's the 4? Yeah, I screwed up again. Man. What should it be? It should be a 4. Thank you. And so on that orange side, can you see that you could use, there's that orange side, you could use the fact that you have a right angled triangle here. The height is 3. How long is the base of that right angled triangle? 2. Mathematically, did you know mathematically when they do this and put a line here and a line here, they mean that those two lengths are the same? Okay? So it's a way of mathematically saying that since they're the same and the whole thing is 4, one of them has to be 2. So now I can do a squared plus b squared equals c squared. 2 squared plus 3 squared equals c squared. Four plus 9, 13 equals c squared. So c will be the square root of 13. I could type that into my calculator, but it'll give me a decimal place. So I'm going to keep it as the square root of 13 right now. And the area of this triangle will be 6 times the square root of 13. Maybe I'll do that on my calculator. 6 times the square root of 13. 21.63. So now my surface area of my prism is 2 of these triangles, base times height divided by 2, plus 24 plus 2 of the 21.63. Type that into my calculator. Oops, 2, 6, 7. I'll just do 2 decimals. Wow. So that was a lot of work just to figure out the surface area of the prism. We had to do extra things to find that orange side. We strategically made mistakes along the way that we had to fix. Again, now we have to look back. Are we done the question? Because sometimes you do a lot of work. No. Where are we at? We figured out this. We figured out this. We haven't. Okay, we could probably write the final formula. And we just need to take away the 2 rectangles. So our final surface area, the first one, we figured out to be 148. Then we would add the 79.267. And finally, we have to subtract 2 rectangles. Can you see that those rectangles are 4 by 6? And so they'll be 24. Type in this whole answer into our calculator. $179.27. I should reread my question. Nearest square foot would be 179 feet squared.